Okay. So today I'm going to explain waves, energy, and electrons using visuals and example problems. So before we get too in depth with anything, I'm going to define what exactly waves, energy, and electrons are. So waves can be defined as a physical phenomenon characterized by its frequency, wavelength, amplitude. So to put that in simpler terms, a wave is how energy travels through space. So why do we learn about waves? What makes them so important? Well, believe it or not, waves play a major role in our everyday life. There are many different types of waves, which I will go more in touch with later. But for now, just remember waves can be found everywhere. Waves are behind everyday items such as radios, TVs, cell phones, and even the reason we see color. So the reason all these items work is because of the 7 types of waves. With radio waves being the first of the 7. Radio waves are usually longer and more spread out, which is their wavelengths, than other types of waves. And then other types of waves include microwaves, which produce heat. Infrared waves are similar to microwaves, but they produce invisible heat. And then there's visible light waves, which produce color, or as seen here, Roy-G Biv. So kind of go in touch with that before I get to the other types of waves. Each color of visible light contains a different wavelength, with red being the largest, most spread out waves, moving down to violet or purple, which contain the shortest visible waves, meaning it has the most energy. So back to the waves. Lastly, there are ultraviolet waves emitted by the sun, responsible for the nice summer tan you get or burn if you experience too many of the UV rays. Then there's X-rays and gamma rays. X-rays allow to see through skin and tissue and can reach bone. Gamma rays, however, are so powerful and the wavelengths are so concentrated due to the enormous amount of energy contained within the rays that allows gamma rays to target and eliminate cancer cells. And then waves can be extremely helpful and found everywhere. So what do we have to thank for all these beautiful and different types of waves? Well, a certain subatomic particle we call the electron is the driving force behind all this energy and all these waves. Electrons produce energy in waves through the 2 processes called emission and absorption. So right here we have emission, and so when electrons get excited, they jump from a higher to lower energy state, which in turn emits light, and hence the name emission. However, on the other hand, absorption is just the opposite. With absorption, an electron moves from a low to high energy state, absorbing light energy in the process, again hinting the name absorption. So now we know all about the waves, energy, and electrons. Let's do a few practice problems in order to find out certain details about waves, such as wavelength and wave frequency. For this certain problem, it states certain radio waves have a wavelength of 120 meters. So it wants us to find the frequency. And although this seems a little vague, we kind of already know where to start, because basically these problems are irreversible with whatever you want. So we want to put the speed of light formula, which we remember is 3.0 times 10 to the 8th. And again, we just put whatever we have, which is 120. We'll worry about our units later. And then we'll just plug that bad boy into our calculator. So 3.0 times 10 to the 8th divided by 120. That gives us 2.5 times, remember our sig figs, 10 to the 6th, and then we're finding the frequency, so we always measure that in hertz. And there you have it. There's how you find frequency.